Somewhere beyond the edge of our solar system, 16 billion miles from Earth, a machine built in 1977 is dying. Not crashing, not exploding, just fading, watt by watt, instrument by instrument. And the most terrifying part? The last message it sends, humanity's only whisper from interstellar space, will arrive 23 hours after we send the command to silence it forever. Think about that. We already know the ending. We've already written the shutdown list. We've already decided which piece of Voyager 1 dies next. The question nobody's asking is, what exactly are we about to lose, and can we even afford to let it go? Nobody told you the real story of what's happening to Voyager 1. The headlines said it loud and then moved on. Another instrument shutdown, another technical update from NASA, another forgettable paragraph buried beneath celebrity news and political chaos. But those of us paying attention to what's actually unfolding 16 billion miles from Earth know that this is not a routine story. This is the beginning of the end of the most extraordinary journey any human-made object has ever taken. And the silence that's coming, the final silence, is going to be the loudest thing humanity has ever lost. Let's go back to where this story really starts, because you cannot understand what's happening right now without understanding what Voyager 1 actually is. Not what the textbooks say it is. Not the sanitized museum exhibit version, the real version. In 1977, the United States launched a machine the size of a small car into the void. No GPS, no solar panels, no ability to repair itself. Just 3 nuclear generators, a golden record, and a mission so ambitious it almost sounds like fiction. The plan was to take advantage of a rare planetary alignment, a gravitational slingshot opportunity that only occurs once every 175 years, and send Voyager 1 on a tour of the outer solar system before letting it drift into the unknown forever. Scientists in 1977 calculated that this probe might still be functional in the 2020s. Most people laughed. Nobody's laughing now. Because here's what they didn't fully grasp back then. Voyager 1 didn't just survive. It became something no spacecraft in human history had ever been. In 2012, it crossed the heliopause. That is the boundary where the sun's magnetic field and solar wind stop having dominance over the surrounding space. Voyager 1 crossed that invisible line and entered the interstellar medium, the actual space between star systems, not the space inside our solar system, the space between solar systems. Let that land for a second. A machine built by human hands, powered by decaying plutonium, carrying a golden record with the sounds of Earth, is now physically located in the space between the stars. And it is still sending data back to us. Or at least it was. But here's where the story gets darker. And it's been getting darker in stages, each stage more final than the last. It started in November 2023, when engineers at NASA's Jet Propulsion Laboratory noticed something wrong. Voyager 1 was still transmitting, the radio signal was still arriving, but the data inside that signal had turned to gibberish. Months of transmissions, months of data, all of it unreadable. Imagine receiving letters from someone in a place no human has ever been, and then one day the letters start arriving, but the words are scrambled. Not missing, not silent, but wrong in a way that tells you something has broken deep inside. That is what NASA was dealing with. A steady signal carrying useless noise arriving from 15 billion miles away, and engineers on Earth had absolutely no idea what had gone wrong. The investigation took months, and this is where you start to understand how different it is to maintain a spacecraft at interstellar distances. When your laptop crashes, you restart it. When a satellite malfunctions in Earth orbit, you send commands and get a response in fractions of a second. When Voyager 1 has a problem, you send a command and then wait. Not minutes, not hours in the conventional sense. You wait 22.5 hours for that command to even reach the spacecraft. Then you wait another 22.5 hours for the response to travel back. That's 45 hours of uncertainty every single time you try to do anything. Every diagnosis, every test, every attempted fix. 45 hours of sitting and wondering whether the thing you just did made the situation better or worse. What most people are not seeing is how this constraint changes everything about the mission. It means the team cannot troubleshoot in real time. They have to plan each command sequence with surgical precision, anticipate every possible response, and build contingencies for outcomes they haven't even imagined yet, all before they send a single instruction. And they're doing this on a spacecraft whose software was written nearly 50 years ago in a programming language that most engineers today have never encountered, running on computers with less processing power than the device you're using to watch this video. By March 2024, the team had made a discovery. They sent a command on March 3rd, essentially asking the probe to dump its entire memory back to Earth, and what came back revealed the source of the problem. A single chip inside Voyager 1's flight data subsystem, the computer responsible for packaging all of the probe's science and engineering data before transmission, had been corrupted. Not totally destroyed, not completely gone, just corrupted enough that it was preventing the entire system from functioning properly. About 3% of the memory in that computer had gone bad. 3%. This sliver of corrupted code was stopping the most distant human-made object in existence from communicating with home. And this is where everything changes, because the solution NASA's engineers came up with is one of the most remarkable acts of long-distance problem-solving in history. They couldn't replace the chip. There's no repair crew. There's no software update server Voyager 1 can connect to. So instead, they did something extraordinary. They took the affected software code and moved it. They split it into sections, because no single section of available memory was large enough to hold it all, and distributed those sections across different parts of the memory system, then reconfigured each section to work seamlessly with the others. A digital transplant performed across 15 billion miles of space, one 45-hour command cycle at a time. On April 20th, 2024, Voyager 1 sent back the first coherent engineering data in 5 months. The team at JPL described it as one of the greatest days in the mission's history. Linda Spilker, the Voyager project scientist, said simply, "We're back in communication with the spacecraft." But even in that moment of triumph, anyone paying attention could see the shadow behind the celebration. Because the memory fix solved the communication problem, it did not solve the power problem. And the power problem is the one that has no solution. Voyager 1 is not powered by solar energy. You can't use solar panels 16 billion miles from the sun. There isn't enough sunlight to collect. Instead, the spacecraft runs on 3 radioisotope thermoelectric generators, or RTGs. These devices work by converting heat from the radioactive decay of plutonium-238 into electricity. They are elegant, reliable, and completely inevitable in their decline. Plutonium-238 has a half-life of about 87 years, which means its heat output decreases slowly but constantly and irreversibly. Every single year, Voyager 1's RTGs produce approximately 4 watts less electricity than the year before. 4 watts sounds like nothing on a spacecraft with a total power budget that has already dropped below half its original output. 4 watts is the difference between a functioning instrument and a piece of dead hardware. According to informed sources within the mission planning community, the Voyager team has been aware of this arithmetic for years. They have known, with mathematical certainty, that the instruments would have to be shut down one by one. And so, years ago, the science and engineering teams sat down together and made a list, a shutdown list. An agreed upon sequence specifying exactly which instrument gets turned off next when the power margin becomes too thin to sustain it. It is a methodical, deliberate, deeply uncomfortable plan. And it is now being executed. The cosmic ray subsystem was shut down in February 2025. That instrument had been measuring cosmic rays, high-energy particles streaming in from distant galaxies, and providing data about the boundary regions of interstellar space. Gone. Then, on October 16th, 2024, something happened that nobody expected. A routine command to activate a heater on board the spacecraft triggered Voyager 1's automatic fault protection system. The probe, sensing something had gone wrong with its power budget, began shutting itself down in a cascade. First, the primary X-band radio transmitter went to low power. Then it stopped transmitting on that frequency entirely. For a period of days, NASA could not find Voyager 1's signal in the data coming through the deep space network. Think about what that means. The engineers who have dedicated their careers to this spacecraft, some of them for decades, were sitting in a room, looking at screens, and the signal from Voyager 1 simply wasn't there. They sifted through everything the deep space network was receiving, looking for any trace of the probe, and eventually they found it. Not on the primary X-band transmitter that Voyager 1 had been using for decades, on the S-band transmitter, the backup transmitter, the one that hadn't been used since 1981, when Voyager 1 completed its primary mission of flying past Jupiter and Saturn. A transmitter that had been dormant for 43 years had spontaneously reactivated because the spacecraft's fault protection system had determined it was the safest option for conserving power. The signal it produced was faint, much fainter than what the Deep Space Network was designed to easily detect. For a period, the team wasn't even certain they would be able to find it, but they did. And on October 22nd, 2024, they sent a message to Voyager 1 to confirm the S-band was working. They got confirmation back on October 24th. 48 hours of waiting, of uncertainty, of not knowing whether their message had even arrived. And even once they had confirmation, they faced a new problem. They still didn't fully understand why the fault protection system had triggered in the first place, and they couldn't risk turning the primary transmitter back on until they knew. Because if they turned it on and triggered the fault protection again, Voyager 1 might push itself even deeper into safe mode, making recovery harder, slower, and potentially impossible. But here's where it gets worse, because everything that happened in late 2024 was just a preview. The real crisis, the slow, grinding, permanent crisis, has been unfolding through 2025 and into 2026. And unlike the communication glitches and the transmitter scare, this one has no fix. On April 17, 2026, engineers at JPL sent a command to shut down Voyager 1's low-energy charged particles experiment, known as the LECP. This instrument had been operating almost without interruption since Voyager 1 launched in 1977, nearly 49 years of continuous science. It measured low-energy charged particles, including ions, electrons, and cosmic rays from both our solar system and the wider galaxy. It detected pressure fronts in the interstellar medium. It helped map the structure of the space between stars in ways no other instrument in history could, because no other instrument in history had ever been in a position to do so. Now it's off. That command took 23 hours to reach the spacecraft. The shutdown sequence itself took more than 3 hours to complete. And somewhere out there, in the darkness between the stars, one more piece of Voyager 1 went quiet. Of the 10 original science instrument sets that Voyager 1 launched with in 1977, 7 are now shut down. 7. That means roughly 70% of the scientific hardware on humanity's most distant explorer is no longer functioning. What remains? 2 instruments, just 2. The magnetometer, which measures magnetic fields in the interstellar medium, and the plasma wave subsystem, which listens for plasma waves in the space between stars. These 2 instruments are now the entirety of what Voyager 1 is telling us about the universe beyond our solar system. 2 instruments, and they are working great, according to the Voyager mission manager at JPL, Kareem Badruddin. But even he acknowledged the uncomfortable truth. While shutting down a science instrument is not anybody's preference, it is the best option available. The power numbers tell the real story. When Voyager 1 launched, its RTGs were producing enough power to run all of its systems and then some. As of April 2026, those same generators are producing less than half their original output. Less than half. And that output is declining by 4 watts every year, with no mechanism to slow or reverse that decline. The math is not complicated, it is not kind. The team is already planning what they call the Big Bang, a single comprehensive power reallocation event in which they will swap out a group of powered devices all at once, turning some things off and replacing them with lower power alternatives, trying to buy the remaining instruments a little more time. The plan was set to be tested on Voyager 2 first, since that spacecraft has slightly more power margin and is just a little closer to Earth. If those tests go well, the same procedure will be attempted on Voyager 1. No sooner than July 2026. Read that carefully. They are testing a last resort power management scheme on one spacecraft before trying it on the other. This is not casual maintenance. This is triage. This is what it looks like when engineers are trying to extract every possible additional day of science from a machine they know is dying. And what is at stake in those remaining days? What exactly are the magnetometer and the plasma wave subsystem still telling us? The answer is something that should make every human being on this planet pay attention, because the data coming from those 2 instruments is genuinely irreplaceable. Voyager 1 is currently the only operating spacecraft outside the heliosphere, the only human-made object actually located in interstellar space and still capable of reporting back what it finds there. The interstellar medium, the plasma and magnetic fields and cosmic rays that fill the space between star systems, has been largely theoretical for most of human history. We could infer things about it from astronomical observations. We could model it mathematically. But we could not measure it directly. Voyager 1 changed that. And when Voyager 1 goes silent, we lose that direct measurement entirely. There is no replacement mission. There is no Voyager 3 waiting in the wings. The New Horizons probe, which flew past Pluto in 2015, is heading in a different direction and is not designed or positioned to take over this scientific role. We are, in the most literal sense possible, about to lose our only ear pressed against the wall of interstellar space. What most people are not seeing is the scale of what that means for the questions we're trying to answer about our own cosmic neighborhood. The interstellar medium is not just background scenery, it shapes the structure of the heliosphere, the protective bubble that shields every planet in our solar system, including Earth, from the full force of galactic cosmic radiation. Understanding how that bubble interacts with the surrounding interstellar environment has direct implications for how we think about the habitability of planetary systems around other stars. It has implications for how we design future deep space missions. It has implications for our fundamental models of stellar environments and cosmic ray propagation. And right now, the only data source we have for direct observation of that environment is a 49-year-old spacecraft running on less than half the power it started with, losing 4 watts every year with 2 instruments left, and a shutdown list that has already claimed 7 of its 10 scientific payloads. There is also a number that puts everything into scale in a way that no amount of technical explanation quite manages to achieve. On November 18, 2026, Voyager 1 will be exactly 1 light day from Earth. That means a radio signal traveling at the speed of light, the fastest thing in the universe, will take a full 24 hours to cross the distance between that probe and this planet. 1 full day at the speed of light, and the probe will continue getting farther every single day. traveling at approximately 38,000 miles per hour in a direction taking it deeper into interstellar space, away from the sun, away from Earth, away from everything familiar. By the time the Voyager mission finally ends, whenever that is, the spacecraft will be so far away that even if we knew exactly where to look, even the most powerful radio telescopes on Earth might struggle to find it. According to what the Voyager team has told us, they hope to maintain communication with the spacecraft into the early 2030s. That's the current estimate, that the remaining power will be sufficient to keep at least one science instrument and the transmitter alive until somewhere around 2030 to 2035. But estimates are not guarantees. Every unexpected power draw, every frost on a fuel line, every unplanned thruster firing, every automatic fault protection trigger like the one that nearly silenced the spacecraft in October 2024 represents a potential acceleration of that timeline. The team has been forced to shut down heaters to conserve power. Those heaters keep the fuel lines from freezing. If the lines freeze, the thrusters stop working. If the thrusters stop working, the antenna can no longer be pointed precisely at Earth. And if the antenna can no longer point at Earth, the signal, already incredibly faint across 16 billion miles of space, disappears entirely. Not because the spacecraft stopped transmitting, because we can no longer hear it. This is not chaos. This is mathematics. And yet, even in the shadow of all of this, there is something that keeps this story from being purely a tragedy. Because Voyager 1 has already done something that cannot be undone. It crossed the boundary. It entered interstellar space. It sent back data from a region of the universe that no other instrument in human history has ever measured directly. It carried the golden record, a 12-inch gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. Out of the solar system and into the galaxy, where it will travel for billions of years after every human being alive today is gone. After the civilization that built it has transformed beyond recognition, after the Earth itself has changed in ways we cannot imagine. That record and the spacecraft carrying it will outlast us. Whatever happens to the signal, whatever happens to the power, whatever happens to the last instrument still listening to the space between stars, the physical object will keep moving, long after we lose contact, long after the last engineer who worked on this mission is gone, long after the Jet Propulsion Laboratory itself might not exist in its current form. Voyager 1 will still be out there, drifting through the dark, carrying human voices and human music and the mathematical logic of a civilization that built something too ambitious for its own time. But that is a comfort that comes with a very uncomfortable edge. Because what we are losing, in real time, right now, instrument by instrument and watt by watt, is not just data. We are losing the ability to listen. We are losing our only direct connection to the universe beyond the sun's protective reach. And we are losing it without a replacement, without a plan, without anything waiting in the wings to take over where Voyager 1 leaves. Off. NASA's current status page, updated as recently as April 2026, shows 2 operating science instruments remaining on Voyager 1. 2, the magnetometer, the plasma wave subsystem, both working well, both sending back data that no other instrument anywhere in the solar system could replace. And both of them running on a power supply that is declining by 4 watts per year with no mechanism to stop it. The Big Bang plan might buy time. The tests planned for 2026 might work. The engineering team at JPL, a team that has already pulled off what many considered impossible, fixing a corrupted memory chip from 15 billion miles away, recovering a signal from a transmitter dormant since 1981, keeping a 49-year-old spacecraft alive in the harshest environment imaginable, might find another solution nobody has thought of yet. These are not ordinary engineers working on an ordinary problem. These are people who have inherited something extraordinary and are fighting with extraordinary intelligence and dedication to keep it alive for as long as possible. But the arithmetic remains. 4 watts per year, 2 instruments left, a shutdown list that has claimed 7 of 10 payloads and will eventually claim the remaining 2, a light day of distance growing longer every single day, and a universe out there beyond the edge of our solar system that we are still barely beginning to understand. So here is the question nobody's quite asking loudly enough. When Voyager 1 finally goes silent, when the last instrument shuts down, when the transmitter can no longer be powered, when the signal that has been traveling from interstellar space for nearly half a century finally stops arriving, what does that silence actually mean for us? Is it the natural conclusion of an extraordinary chapter, a kind of dignified ending befitting the most remarkable journey any human-made object has ever taken? Or is it something more uncomfortable than that? A measure of our own limitations, a reminder that we sent one machine to the frontier of our solar system nearly 50 years ago and have not yet sent another. Is it a pause in the story or the end of it? Right now, Voyager 1 is still out there, still measuring, still transmitting, Still, after 49 years and 16 billion miles of travel, doing exactly what it was built to do. But the window is closing, the power is fading. The list is getting shorter, and somewhere in a room at JPL, engineers who have spent their careers listening to a machine in interstellar space are already calculating, with quiet precision, exactly which instrument they will have to shut down next, and when, and in what order, because the ending has already been written. The only question left, the one that hangs over all of this, like a question no one wants to answer, is whether we will have the wisdom and the urgency and the ambition to make sure it is not the last chapter we ever write in this particular story. Because Voyager 1 carried humanity's voice into interstellar space. And right now, that voice is getting quieter, instrument by instrument, watt by watt. And the universe, for the first time in nearly 50 years, is starting not to hear us anymore.